All right, welcome back. Notating domain and range straight from a graph. Here's the issue that we're having, okay? If you, oh, I'm not even on the screen. Nobody told me, sorry. Here we go. We're good? If you want to tell me where you can find this heart, okay? We run into a little bit of an issue where if you tell me, hey, I think that the heart is right here, and you pick the very middle dot of this heart, that is a place where, where the heart could be found, but it's not every single place. We need to list in our domain every single place where you could find the heart. And the problem with that is, well, we'd have to list this number right here, we'd have to list this number right here, we'd have to find this coordinate, we'd have to find this coordinate, we'd have to list all of these coordinates. But the real problem is, that's not even enough. We would also have to find, what about this spot? That's where the heart is, and what about this spot? And what about this one? And then, after we got 10 more of those in green, then I could go back with the black pen and I could say, oh, what about this little spot? The bottom line is, naming coordinates is not good enough. Okay, we have a big shape and we have to list every single place that we can find this shape. Now, our strategy is going to be like this. First of all, we're going to think about this heart as a box. Okay, we're going to make this heart into a nice rectangle or square, and we're going to think about this heart as a rectangle. Okay, and what we're going to do when it talks about domain, and remember domain is our left and right direction, we're going to think about, you see I've got my little thing here, we're going to think about where is that heart, almost like we have some sort of like high-tech sensor. Okay, so imagine this, we're scanning for the heart, it's like beep, beep, beep. You following me? This is only where the heart is. We need to figure out where is this. In order to do that, we're going to find out what is the left of the heart, and we're going to find out what is the right of the heart. If I was you, I would write those words down. Now, like I told you before we started, the hardest thing we have to do is count to 7 today. Okay? If I am trying to look for my heart, okay, and look at my stick thing that I have here. Can I find the heart over in this area?
No.
No. Can I find the heart in this area?
No.
Where is the very leftmost edge of the heart? It's right here. Do you agree with that?
Yeah.
Okay. And once I've found that very leftmost part of the heart, I need to count in the x direction. Where does that show up? You ready? 1, 2, 3, 4, 5, 6, 7. Just like always, count from 0. And even though I counted to 7, this is at left. And so this is negative x direction. So really this is -1, -2, -3, -4, -5, -6, and -7. So here's the good news. I said the hardest thing you have to do is count to 7, and we already did it in the very first question. So it's all easier than that from here. Now, if I've got this leftmost region, can I find the heart at -6, -5, -4, -3, -2, -1?
Yes.
What about 0? No, right? So our heart has stopped. What is the rightmost edge of the heart? -1. And we're pretty much done with this question, but here's where students start to get a little bit scared. They have this one moment where they go, ooh, and then they just fall asleep, right? And I don't know what to tell you. You got to be braver than that. In the middle, we need to say that all of our x's are in between these numbers, right? Our x could be -3. Our x could be -3.5. Our x could be -3.25. But our x's have to be in between these numbers. And here's how that looks. A less than or equal to sign, an x, and another less than or equal to sign. And again, I know that for the first time you see this, it looks a little scary, but all that this means is that the x is in between the numbers, okay? What we have just said is that the heart can be found anywhere between -7 and -1. Now, that is a really good start, but that's not enough.
Wait, hold on, Mr. Carter.
Hold on. You got a question?
Yeah.
What is it?
So how can x be less than or equal to -1? Like, how can it be less than -1?
Because it could be -2.
No, but that would be greater, right?
No.
No, because it's negative.
So it is weird, but just like look at the wall counter there, right? 3's up on the ceiling and -3's at the height, right?
Yeah.
If you're going up, you're going greater. If you're going down, you're going less than. It is very tricky to think about negative numbers. That is not a weird thing to think. Now, we're going to have to change our brain. Here's the second place that people get confused. We're going in the x direction, right? Cool. We're finished with the domain. It looks great. Now, we have to change our brain, and we have to do in the y direction. We have to scan low to high. Now, again, those are important words here. We're going to have to scan from low to high. One of the most common mistakes is that students take the -7 and the -1 and they put them in the wrong, they swap them around, right? So -1 is first and -7 is second, and that would be wrong. So I think that these left, right, low, high, those are actually really important words. So what is the lowest place that we could find our heart?
0.
I agree with you. It is a 0 y value. I think that's perfect. It's not at -5, it's not at -4, not at -3, not at -2, not at -1, but at 0, that's where our heart starts. So we're going to put a 0 here. Then, what is the very top limit of our heart? 1 is good, 2 is good, 3 is good, 4 is good, 5 is good, 6 is good, 7 is bad. So 6 is the highest place that we go. And here is where, there's probably people moving ahead of me and you've already kind of got this one a little bit wrong. What goes in the middle? Less than. What goes after that?
Y.
A y. Why is it a y?
Because it's the y-axis.
Because we're doing the range, right? Domain is all x's, range is all y's. So, the reality is, take a deep breath. Literally, you just had to figure out what was the left side of the heart, what was the right side of the heart, what was the bottom of the heart, what was the top of the heart. That's the 4 numbers. That's all we had to do. Question?
Well then, so you said the last one's negative, but how come 0 is... Bro, shut
Relax,
up.
hey,
How come
relax.
0 is less
Yeah.
than or greater, less than or equal to y? Y is
Right.
less than or equal to...
So that's basically saying that y has to be bigger than 0, because the alligator eats the y. But
Zero is
also-
less than y. Less than or equal to y. Okay, that makes more sense.
Right. So 0 is the bottom of the totem pole, y is in the middle, 6 is on top.
Okay.
Okay. All right, wait on everybody to be quiet again. We're going to move on. As far as the function goes, I don't really care about the function for this stuff.
Wouldn't that be no?
It would be no. You're correct. But again, we already know how to do the function stuff. Let's look at number 2 here. I'm going to go about 10 times faster here. You may already be done. Check your answers for this part. Shh, we got a whole lot of bickering going on. You just to be quiet. We got a nice rectangle on our McDonald's M, the golden arches, if you will. And when we got that set up, we're going to look for 4 numbers. It's going to be the left, the right, the low, and the high. All right? In the middle of those, the domain is going to be less than x less than, and the range is going to be less than y less than. All we got to do is figure out 4 quick numbers. We get 4 numbers, we're done. We're moving on. This is allegedly one of the most missed questions on the entire SOL test. All you got to do is give me the lefts, rights, lows, and highs. So let's start with the left. Negative 10 is bad, negative 9, no, negative 8, no. Where is the very first place that this M shows up? Negative 4 is correct, right? In the X direction, negative 1, negative 2, negative 3, negative 4. Negative 4 is our leftmost bound. I'm good all the way negative 3, negative 2, negative 1, 0, 1, 2, 3, 4 looks bad. So what is my rightmost region? It's a 3. Sweet. What is the lowest place that my M is? 0. Don't interrupt me. And what is the highest place that my M is? 1, 2, 3, 4, 5, 6. 6. And that's what we got. All right. I will give you 3 minutes
I have a question.
to try the star question in the bottom corner. Can you try to figure out the
I
star?
have a question.
Can you figure out the star? We're going. Timer's going. 3 minutes.
Would the M,
I'll be right there.
would the M count function?
Honestly, like I said, when we said this, that part's weird, you know what I'm saying?
But
So,
like, imagine being looking at a very thin line, I don't think it would.
if it was a very thin line, it would probably be yes. If that big line, it's probably a no.
Finished? Thank you. All right, we're being quiet. We're focused on our own paper. We don't even need to interact with anybody else. If you got an answer, raise your hand. Let's see how you did.
Okay, give me that. All right,
Go ahead. I got my timer going.
my timer's at 1 minute, so you got till 7. Yeah, one of them is you got till 3:03.
Left, right. Like start writing something down. Right. Write your left, right, low, high.
Okay.
For domain, she's not
I think
getting
it's looking
anything.
pretty good.
Yeah.
Oh,
Okay, let me try one more.
You okay? We're going with about a minute and a half till we go over this together.
What?
That looks good. But what about the range? Think you got this part, the left, right part? Or what about the low, high part? Oh, I see. It looks good. Put that middle stuff in there. That looks great, Kyle. Nice
It's
job.
not gonna be 0.
You just count down. Where is that? You know? Just count all the way down until you get to the bottom. Nice job.
I think I'm doing
Did he help me?
Yep, I'm coming.
How far I got
What
it?
y'all get?
Did I get 9?
The domain is closed or wrong?
No, for the left to right. I got negative 8 and then 0.
Alright, so what is the all the way to the bottom of the star?
I'm right. I got
This shit hard, but you're in the middle, so how's that high?
negative
Right.
You're not voting.
Yeah, oh, shoot.
Alright.
Mr. Cole, your picture.
It's
Wouldn't low be?
It's close, the domain looks excellent, the range a little off.
Is that right?
Wait, for which one?
Ooh, closer, but still just a tiny bit wrong. Also very close. Okay, that's our 3 minutes. We're gonna have chances. We're gonna have chances to go through this more
Negative 8 for.
together. I want my left and my right. I want to get the low number and the high number. I know that the domain has my x's in the middle. The range has my y's in the middle. Now, if I look at my star and I'm looking for the left, and again, if you haven't been doing this, make a nice box around your shape. This box helps a lot of algebra students because it helps me line up my line. What is the most left that we go?
Negative 8.
You're correct. Negative 8. All right. Welcome back. Thank you for being on time. After we got negative 8, what is the very rightmost place we can find our star? It is a 0. It is a 0 because right here, that's the 0x value, right? It's if this is negative 8, negative 7, negative 6, negative 5, negative 4, negative 3, negative 2, negative 1, and what comes after negative 1? 0. There it is. 0 is the rightmost region. Now, let's go low to high. My star is all the way at the bottom, right? That's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, negative. You guys are right. Negative 10 all the way at the bottom. And then what is the very tippity top of my star? Negative 2. So the star is 8. So hold up. Just take one deep breath. You're right. The star is 8 tall, but if we count, that's negative 10, negative 9, 8, 7, 6, 5, 4, 3, 2. The top of it is at 2. So you're not really counting how big the shape is. You're trying to count off where are those edges. Okay, now, here's where a lot of students, they're doing a good job. Hold up, just trust me. Here's where a lot of students are doing a great job, and then all of a sudden, Dre, there's certainly better things we can do with our time than that. And then all of a sudden, they think, you know what, I got this, I'm going to fall asleep. And here's what I got for you. We have a U-shaped graph. I'm going to take my highlighter, and I'm going to put a highlight around this U-shaped graph. When it comes to domain and range, guaranteed on the SOL test for Algebra 1, on the SOL test for Algebra 2, U-shaped graphs are huge. U-shaped graphs are very important. And if you don't listen to me for the next 5 minutes, I swear you will miss every single U-shaped graph for the entire year. Like it's that serious, okay? I haven't said that kind of extreme hyperbole in weeks. This is super important. Number 1, look at these very tippity tops of my U. What do you see there? There's arrows. And here is a very important thing. When there are U-shaped graphs, they always have arrows on top. And when there are U-shaped graphs, these arrows are always diagonal. Even if they look like they are pretty much going straight up in the air, they are always diagonal. Okay, and that makes a huge difference. So every time you see a U-shaped graph, they have arrows, and the arrows are diagonal. Now, what does it mean if you see arrows on a graph?
That's so extra in math, like.
It is a little extra because it means that the arrows go on forever. Now, you guys remember that? Like when you're looking at a line, if it has arrows, it goes on forever. So here's what we got. This arrow means that we are going up forever because it is an arrow that is pointing up. But here's the thing that the kids who fall asleep, they never get this part. This arrow, which is diagonally, also means that we go to the right forever. Now, deep breath. If you think that these U-shaped graphs are getting really complicated, I got good news for you. They're actually easier than the ones that we just did. So you gotta trust me for another 30 seconds, and you'll see why. Okay? Over here on the left, this arrow means that we're going up forever. Oh, I forgot a couple letters in there. There we go. Up forever. And it also means that we're going left forever. Watch your mouth, please. We're going left forever. Now, I have to be... So, a very good point. I don't like necessarily the words that you said when you said it, but I do like the point that you made. Even if we're running out of room on the graph, right? Like, look at this arrow. It's already in the corner. It still goes on outside of the graph. So, if we think about this graph right here, this graph keeps going even this high. The graph keeps going even this high. All right? The graph literally is going to go it's going to keep going. It's going to keep going up. Even up here, even on the top of the page where it says your name, the graph is going to keep going. And we have to trust that if you see those arrows, the graph, look at it, it's going to go forever. That's what makes this actually easier. Because when, you're on the right idea, when we're thinking about the domain, this graph, it goes up forever, but it also goes to the sides forever. So if I look over here, could I find my graph over here?
Yes.
Yes, because even though it doesn't look like it right now, the graph's going to keep going and it's going to touch the line. Could I find the graph over here?
Yep.
Yep, because it's going to keep going and it's going to be over there eventually, right? Could I find it over here?
Yes.
Yeah, it's going to keep going. Look, I'm even, oh, this is crazy. Look at that. That's crazy talk. Yes, here's what's going on. The graph goes forever in both directions. So, we're going to bring it all back.
So it goes,
The domain, it starts all the way over here at negative 10,000, and it goes all the way over here to positive 10,000. It goes forever. So, what do we put for the domain? It's something that we've heard before, ARN. Why are U-shaped graphs easier? Because you don't have to find any numbers. You literally just write ARN, done. Okay?
Why do you wait till it's step from the jump?
Because if you don't understand why it's ARN, it gets very confusing very quickly.
The arrows keep going and keep going and it's ARN.
Well, that's pretty much what I said.
After 5 minutes.
After 5 minutes, okay, maybe that's right. Now, I hear you. Now, hold up for 1 second. The reason that I needed to explain it is because a U-shaped graph, I agree with you guys, is pretty simple. It goes up, it goes to the sides, but does my U-shaped graph go down?
no.
No, there's no arrows pointing down. So, here's an important piece here. We're almost done because the two questions on the back are literally 10-second questions. Look at this. My U-shaped graph is up here. My U-shaped graph is right here. My U-shaped graph is right here. Shh. Relax. What is the lowest place that I can find my U-shaped graph?
-4.
The lowest place is right here. Yeah, we're still here. We're still here. Because we figured out the domain. We talked about left to right, but we didn't talk about the range yet. The range. Would you agree that if I look right here at -7, there's no graph? There's no graph. -6, there's no graph. -5, there's no graph. But once I get here to -4, there's a graph. Okay, sounds good. So let's put that in. What is the lowest number that I can find my graph?
-4.
-4, okay. And what is the highest number that I could find my graph?
ARN.
ARN also includes the low numbers, so we can't quite put that. I like how you're thinking. What we can put is infinity. A little infinity symbol, because we go up forever. Listen, we're doing a lot. It's like a sideways 8, right? Now hold on for just a second, because if you let me speak, hold up. Okay. If you let me finish, you'll see you don't actually ever have to write an infinity symbol. Okay. So, once we get this set up, here's what I'm trying to tell you before we kind of had a whole bunch of chatter going on. In Algebra 1, the low number is -4, the high number is infinity, but here's the good news. in Algebra 1, you don't have to write the infinity at all. You can just, this whole half over here, you don't have to write it. Now trust me, cross it off. You don't have to write that part. But the reason that we did that, because I'm not, making you do extra work for no reason. The reason that we have to do this is because the y has to come first. Okay? And you see how it's set up right here? The y is not coming first. So we have to write this like this. Y negative 4. And the reason that we did all this is because you see how I don't know if you guys remember like 3rd grade. Do you remember how the alligator eats the big number?
Yeah.
Okay. And which person is the alligator eating? The 4 or the y? The y. And so when we write the y first, the alligator still eats the y. So we did all that work.
So y is greater than or equal to negative 4.
Right, and that makes sense because here's negative 4. Where's the graph? Above it, right? The graph's up here. The graph is above negative 4. Okay, flip the paper over. We're going to be done in a second. Here we go. Straight lines. I don't want to call names out while we're recording, but I will. Be quiet. Facing forward. Facing forward.
Oh wait, this is easy.
Okay, we're going to start with this diagonal line. Do you see that it has arrows?
Yeah.
Are these arrows diagonal or what?
Diagonal.
Diagonal. If they're diagonal, that means that they go up forever and they go to the side forever. What about this arrow? This arrow goes which 2 directions?
Down and left forever.
You're right. It goes left and it goes down. So, talking about domain first. Does our graph go to the left forever?
Yep.
Yes, it does. Look at this symbol. It keeps going. It goes forever. Does our graph go to the right forever?
Yes.
Yes. If I go over to 10,000, am I going to find the graph over here?
Yeah.
Yes. So what is our domain going to be?
ARN.
ARN. Nice job. That's because it goes left forever and because it goes right forever. Now with the U shape, our range was kind of complicated. With this line, do we go down forever?
Yeah.
Do we go up forever?
Yeah.
So what's our range going to be?
ARN.
ARN. So remember, these straight lines, they're pretty easy. I didn't put a highlighter box on the straight lines. I put a highlighter box on the U-shaped because those U-shapes are the killers. All right, last one. Look at this graph. We have this arrow right here. Is this a diagonal arrow or an only sideways arrow? Right, this is a only sideways. So what that means is this line, it goes to the right forever, it goes to the left forever. But does this line go up and down? No. Okay, that's going to make our range a little interesting, but the domain is easy. Do we go left forever?
No.
Do we go right forever?
Yep.
So what's our domain going to be?
ARN.
ARN. Again, this is getting way easier. It's getting way faster. It's not getting harder. We're getting better. Here's our range.
Is the range just 6?
I like how you're thinking. Can we find the graph up here? If I look up here, is the graph going to be up there?
No.
If I look down here, is the graph going to be down there?
No.
Where's the only number when we're talking about the y values that I can find that line?
6.
It is at 1, 2, 3, 4, 5, 6. And that's the only place, right?
We just put 6.
So we put y equals 6. Because what is the only place we can find it?
6.
Y equals 6. Okay, before we end this, if you have a box, those actually became one of the hardest questions because you had to find 4 different numbers. If you had the U-shaped graph, one of them was ARN, but one of them was a nice simple inequality. Those U-shapes are kind of tough. And on the back, the straight lines, pretty freaking easy, right? Diagonal, ARN, ARN. A straight line, ARN, y equals 6. All right, domain and range. This piece of paper, I would keep this piece of, I would keep this. Because every time you get to a U-shaped graph, you pull this out, you look at this, it's going to help. Okay? This video I'm recording now, it'll be on YouTube, it'll be on Canvas. Go back to the YouTube video and check it out.